Next up, it gives me great pleasure in introducing the solution architect from THL, who will go through their journey with MongoDB Atlas, hailing from Auckland, New Zealand. Please give a warm welcome to Charbel Abdo.
Thank you. Thank you. Hi, everyone. Thank you all for joining. So my name is Charbel, and I've been a solution architect at THL for 5 years. And during that time, I've had the chance to work on some performance, cost, and stabilization projects. And if you remember the keynote today, it was mentioned that some companies use what we call a bolt-on approach to put additional systems, to use additional system with their main platform, in our case, MongoDB. And so we are one of those companies that does this. And actually, we were doing this. And today, I'm going to talk about why we did this, the pain points that we faced with this bolt-on approach, how we got rid of it, and how we migrated out of it, and the benefits we got from that. But before we go to the techie stuff, let me introduce my company a little bit, give a bit of background about what we do, what our solutions are, and how we use MongoDB, what kind of technologies we use. Come on. Work? Yep. Is it working? Okay. Facing a bit of an issue here. Okay, there you go. Okay. So we are THL, Tourism Holdings Limited. We are the largest RV rental company in the world. We are a New Zealand-based company. As they mentioned, I'm coming from over the ditch. But we are global. We have branches in New Zealand, Australia, the US, Canada, and the UK and Europe. Our model is to build, rent, and sell. So we build camper vans, we rent camper vans, and then we sell camper vans. And as such, we have many brands under our umbrella. Don't worry, I'm not going to mention all of them. Some of them are for rentals, others are for retail, selling camper vans. We also have some manufacturing brands, such as Action. We also have a couple of tourism operations in New Zealand. Those would be Waitomo Caves, Discover Waitomo, and Kiwi Experience. Focusing on our rentals, if you've driven in New Zealand and Australia, you might have run into some Mauis, some Apollos, some Ritz camper vans. That would be us. In the US, we have El Monte and Road Bear. In Canada, we have Canadream. And in the UK and Europe, we have Just Go and Bunk. And all these brands are using our in-house platform that we call Motec, which is our in-house solution. So let's talk a little bit about our technologies, our solutions, the Motec ecosystem. Motec is our in-house booking, pricing, availability, fleet, and scheduling system. And I'm sure I'm forgetting something. It's built on a microservices architecture in .NET. It uses MongoDB Atlas as its main database, or what we like to call our source of truth. And it also acts as a backend API service for our other solutions. So if you were to book a camper van to go on a holiday now, you'd start by going to one of our B2C sites, where you can search for a camper van and book a camper van. And again, this would flow into Motec using our APIs. You might even go to one of our trade partner sites, our third-party trade partners. And under the hood, it's very probable that they are also hooking into our API system. A couple of weeks before you go on your holiday, you would use our self-check-in app to enter your information, pay any outstanding amount that you have, and save yourself some queuing at the branch. Once you're on the road, you can use our THL Road Trip companion app to basically find interesting campsites, interesting activities, troubleshoot any problems with your camper van, or simply learn about the features you can use. All our vehicles are fitted with a telematics device that would send information such as location, high-speed events. Yes, we would be watching that. Engine on off, engine problems. And we can also use it to define some geofences or restricted areas. We used this in 2020 in the famous Australian bushfires to put some restricted areas and warn people if they are about to go into a dangerous area. And finally, you can imagine that all of this would generate lots of data. And all of this data flows into our data warehousing and reporting solution for analytics and reporting. Okay, let's talk about MongoDB. How do we use MongoDB? What you're seeing here is the Waitomo glowworm caves. If you're ever in New Zealand, don't miss them. It's an awesome experience. Okay. So we use MongoDB Atlas as our main database for the whole Motec platform. We also use MongoDB Atlas Device Sync to send notifications to the onboard computer on vehicles. And this one was such a special case, and it worked so smoothly that MongoDB did a case study on it that you can check if you're interested by using this QR code. We use MongoDB Atlas App Services that was previously called MongoRel, that was previously called MongoStitch. For some of our trigger-based jobs, such as data singing. For example, the process that we have that sends data to the data warehouse listens to some 40-something collections and sends all this data to our warehouse. We also use some minor CLI tools like Mongo Import, Mongo Dump, and Mongo Restore to sync data between environments and for some of our data import flows. And finally, we use MongoDB Atlas Search for some complex search functionalities. Now, just a year ago, we were not using MongoDB Atlas Search, as I stated at the beginning. We were using another search engine. In our case, it was Elasticsearch. And we used the bolt-on approach, where we sync data to Elasticsearch. So let's talk a little bit about that bolt-on approach that, again, was mentioned in today's keynote. So when you say a bolt-on approach, it simply means that you are bolting on a separate search engine or whatever. This morning in the keynote, it was mentioned, I think, in the context of vector search and data streaming and also full-text search. In our case, we're talking about full-text search or a search engine. And so you bolt that search engine, and you set up one-way data sync from your main database to that search engine. And then, obviously, when you need it, you query data from the search engine, or Elasticsearch in our case, instead of your main Mongo database. So we had some complex screens where we needed to do this kind of complex queries. And at the time, Atlas Search was not live yet. So I think Atlas Search went live in June 2020. And at the time, we were already in testing phase, so it was a bit too late for us. So we decided to use Elasticsearch in that bolt-on approach. But wait, that wasn't enough for us, right? We came up with a brilliant idea where we said, what if we can get all consumers to query whatever data they want without having to do any kind of back-end changes, without having to go to those back-end developers and ask them to add a parameter or something? Obviously, MongoDB is not good for this because you would have to index every single combination you can think of. So instead of just syncing the data that we need to query in a special way, we decided to sync all the data to Elasticsearch. And we implemented this using this architecture here, this very simple architecture. We have a bunch of microservices, and on any create, update, or delete, they would send a message that would be intercepted by a worker, which would then send the data to Elastic. And more importantly, we had a MongoDB trigger that was also listening to dozens of collections and basically doing the same thing, syncing data via HTTP calls to Elasticsearch. And that worked quite well until we went live, that is. So let's talk a bit about the pain points with such an approach. So the problem started a couple of months before we went live. We started by going live in New Zealand and Australia, and at the time, we were preparing for the go live by doing some performance testing, more specifically some load testing, and we had very high response times under stress. And once we investigated, we found that our most critical process, which we call price and availability, where you search for a camper van basically online, was using an Elasticsearch feature called Percolator. Now, it's a very nice feature. It allows you to query your data based on a set of rules that you can put on every document. But it's also a very expensive feature performance-wise. And so here's the first problem. If you want to use two databases, which is effectively what we're doing here, right? It's going to get really expensive if you want both of them to be a high-tier cluster. But if you go with a low-tier cluster instead for your bolt-on database, which is what we did, you're obviously going to run into performance problems. OK, so we got rid of Percolator, replaced it with some good old boring Mongo queries and some indexes. Life was good again. But wait, you can tell me here, like, this is a problem that you can throw money on, right? Like, you can just, what is $100,000 extra per year in the grand scheme of things? Like, you can just throw money at the problem, and you wouldn't have that. Well, here comes the next part. Keeping data in sync is a very difficult task. And we found this the hard way. There's a reason why only large companies do something like this. So you saw how simple the architecture we set up was in the previous slide, right? And that worked maybe 99% of the time, maybe 99.9% of the time. I don't know. I never bothered to measure it. But when this 0.1% of the time happens, your data gets out of sync, and then it's really painful. And we all know it's going to happen, right? Like, I don't know. You have a bug in your code. It happens sometimes. Elasticsearch goes down. Your sync worker goes down. Something happens. Like, there are engineering solutions for all of these things. But again, that's a lot of wasted effort, right? You can put a lot of effort into designing something that works almost 100% of the time, but you're not creating any value. You're not increasing revenue. You're not creating customer value. You're not doing anything, except maybe being proud that you're syncing two databases. I don't think execs would really care about this. I'm going to talk about one particular issue that we had, which we had nicknamed the Friday afternoon P1. So every week, we had a process in THL where we need to insert/update a large amount of data. And when I'm talking large amount, I'm not talking billions here. I'm talking 500,000 to 1 million records, maybe. And again, this is why we have a premium Mongo cluster, right? So that we can insert 1 million records in peace. Like, we don't worry when inserting something like 1 million records in the database. So remember, we have a MongoDB trigger listening to those changes and sending this data to Elasticsearch. And what would happen once these million records started going in, that MongoDB trigger would start sending this data to Elasticsearch, basically bombarding Elasticsearch with new requests. And slowly but surely, Elasticsearch would start to crumble. Now, the MongoDB trigger, under the hood, for those who know, uses something called an op log, an operations log. And this is basically keeping track of all the changes that you made. And this is what enables those triggers to work. With Elasticsearch taking more and more time to process the request, this op log would start emptying slower and slower and slower until it eventually floods, and that trigger would get suspended, and we have data loss. Our data is out of sync now. And here comes the next problem. So it's Friday afternoon. Your data is now out of sync. How do you fix it? Do you, I don't know, like Do you try to guess the last timestamp where that data failed and try to sync that data from that point in time? I think that's a bit difficult, especially if you're using something like 40-something collections and you're not going first in, first out, because that obviously would be very slow. So that doesn't quite work. Do you sync everything from the previous day? Because you would capture everything like that. Well, you've just recreated the same problem, right? You're going to sync a couple of million documents again, and you're going to have the same problems. Do you create some fancy solution where you have some flag on every document that determines if that thing went to Elasticsearch or not, and then create another process that resyncs all the documents that didn't go to Elastic? We did something similar. We called it regurgitator, which is a very creative name because it regurgitates all the data that was missed from Elasticsearch. Again, lots of engineering effort, absolutely no value to show for it. No increase in revenue, no happier customers, nothing. Basically just more P1s, more issues, and unhappy managers. And yeah, I also need to mention, obviously, that devs would need to learn multiple technologies, but also maintaining 2 clusters is time-consuming. So, upgrading a cluster is not something done lightly. Even if you have no breaking changes, you still need to do some regression testing. You still have to do it on lower environments first. In our case, Elasticsearch was on a very old version, and we neglected to update it because it was a breaking change. So just to show the extent of the problem that we had, if you go to Elasticsearch documentation, I will never forget this, there's a drop-down at the top left that specifies the version that you're looking at. So anytime we needed to use that documentation, we had to open that drop-down, shamefully scroll to the bottom where it says show older versions, click on show older versions, and then scroll down again to get to the version that we were using. That's never a good sign. Anyway, with all these P1s, all these issues, we finally built a business case, and we got permission to finally migrate to another solution. And another thing that was said in the keynote today, I felt personally attacked this morning, was that taking the decision to do a migration is harder than the migration itself. And that was certainly true for us. So after 2 years of coming up with very creative solutions for this problem, regurgitating data and doing, I don't know, all sorts of things, the whole thing from start to end, and I'm giving a spoiler here, took a couple of months. And that wasn't even a full-time job. We were doing this on the side. So to get this done, we started by determining the scale of the problem. We just looked at our logs. We're like, oh, this is using Elasticsearch. This is using Mongo. Let's just document all these things. We communicated with our MongoDB account team. Thank you. And they got us some recommendations and validated our use case. We can use Atlas Search, where we can use MongoDB. Remember, other than the generic kind of querying Elasticsearch, we also had some complex data. So we planned on how we're going to migrate that data and create the complex queries, if you want. And we did a bit of ramp up on Atlas Search users, which wasn't that hard. We just created a few indexes, played around. And then we used a kind of iterative approach to the migration rather than going full on. Every week during the sprint, we would say, OK, let's just migrate 4 or 5 indexes this time. And the migration itself wasn't that hard. Like, we would determine if that should go to plain MongoDB or to Atlas Search. We would create indexes if needed. And then if something required Atlas Search, we would rewrite the queries using the MongoDB C# SDK. And finally, we would monitor the whole thing using Mongo Atlas Query Insights, or what was called the profiler. Can you please stop changing those names? And yeah, that was it. A couple of months later, we had migrated everything, and it was done. Just a couple of notes. Again, like any new technology, even if it's very similar, it will need a little bit of ramp-up time. So both Atlas Search and Elasticsearch under the hood use the Lucene engine. So it's a very one-to-one migration. We were able to migrate the tokenizers, analyzers, everything in an almost one-to-one fashion. But there will still be minor differences. It's just something to mention. I can recall just one, which were in Elastic, when we were querying the data, we were sorting by date at the end. And for some reason in Atlas Search, that was very slow. There was a performance problem there. But again, with some research and some communication, we were advised to use the near operator instead of sorting by date to kind of modify the score rather than sort directly by date, and that worked beautifully. And I even think that this was fixed in subsequent versions of Atlas Search. And again, kudos to the MongoDB account team. They were exceptional. They set up some weekly meetings with us to follow up on the progress, even without us asking for it. And they also set up some direct communication channels. We did try not to abuse that. OK, the achievements. What did we get out of this? What did we show to the execs when all this was done? So the most obvious one would be cost saving. We were able to turn off our Elasticsearch cluster. And even if it was a low-tier cluster, it still did cost quite a bit. We were also able to turn off our 2 sync workers, which were very expensive. These things were processing millions upon millions of records per day. And as an added bonus, because we had a bit of buffer on our MongoDB cluster, we did not have to upgrade our cluster at all. So pure win in that regard. The second one would be all data sync related issues were gone, eliminated. We didn't have, we had a sharp reduction in P1s that finally made managers very happy, but also we got our Friday afternoons back, which is always a good thing. Our code base got simplified. We removed all the code related to that fancy redirection that we were doing with Elasticsearch. We also had some NuGet conflicts because of how old our SDK was, which we were able to eliminate as well. We had a reduction in maintenance overhead. Our DevOps team was also happy. See, we're making everyone happy. We can use our existing MongoDB support plan for any issues that we face. We didn't have that previously with Elastic, again, because we were using a low-tier cluster. This is not a jab at Elastic, but if you use a low plan, that's what you're going to get, right? We can also use our existing monitoring tools rather than having to set up something completely separate for the standalone search engine that we were using. And of course, at the end, a couple of lessons learned. OK, this has been said maybe 1,000,000 times already, but it can't be repeated enough. Over-engineering is bad. Simple is better. Over-engineering bad, simple better. So like, even if we didn't go into the whole, hey, we can query anything without any backend changes, it would still have been problematic. But the problem wouldn't have been amplified like it was in our system. We wouldn't have that many P1s. And the migration would have been much easier, even though it wasn't that hard. But still, it would have been even easier than that. Consolidate. If you are using a tool, you're already paying for that tool. Use that tool to the maximum extent possible. And that doesn't only apply to MongoDB, right? Whatever you're using, before looking at other fancy solutions like we did, look into what you already have. Get the most bang for your buck, in a way. And finally, sometimes changes are easier than you think. We spent 2.5 years with our faulty solutions just looking for ways to patch up all the problems that we were having. whether by creating workers that replay messages, by coming up with some fancy alerts. Like, we tried everything except actually looking into how much would it actually take to migrate that thing. And once we did, it was quite easy. Like, we wasted so much time, so much effort, so much money, while if we had thought about this a couple of years ago, it would have been a breeze. Finally, thank you everyone for listening. If you have any questions or you want just to have a chat, I'd be outside. Thank you. Enjoy the rest of your day.